Okay, I think I did it. We will see.
Excellent.
All right. Thank you, first off, Andrew, for meeting. All the times that we've met and talked about data and the importance of data. It's been a lot of fun, to say the least. And I'm excited to talk to you guys today about data and how it's expanding beyond the traditional walls of the data center, as we call it. Let me bring up the presentation. Hopefully I got this correct here.
And that's Darren's family, 10 children. Oh my goodness.
There's a lot of us, that's for sure. So to talk about data a little bit, first off, I want this to be somewhat of a discussion. The group's not too large, so if you guys do have questions, you can go ahead and ask. Just come off mute, interrupt me. Andrew knows from our conversations that we've had that it's best just to interrupt me. Otherwise, I can go on for hours. So we will limit it to the time that's been allocated today, though. But I want to give a brief history of data-centric transformation that we're seeing today and where it all came from. Because when we talk about change, it's good to know where we were coming from, because that will influence where we're headed quite a bit. So, and we can see today this huge push that we've seen with Internet of Things. In fact, a lot of people believe that we would have been a lot further along with Internet of Things. And a lot of people blame that 5G rolled out too slowly. Everyone was waiting for 5G to really make Internet of Things happen. But actually that's kind of everyone just saying the data problem will be fixed with faster networks. But what people didn't realize is all of the data that's being collected on the edge or outside of your data center is a lot more data than what people realize. The number of sensors, more high-def cameras, it's just exploded. There's estimates that we've got anywhere from 20 to 30 billion connected devices now out there outside of the data center, which is extraordinary. A great example of this that most people don't even know about is your automobile. Your cars have been communicating data back to their manufacturers for probably close to 15 years now. If any of you have heard of OnStar, OnStar is one of those things where it's collecting data on how the car is operating, and it sends that data back up to GM. And they've been collecting that data for years. Almost every automaker collects that data today, to the tune of about 240 kilobytes per minute, which doesn't seem like a lot. But when you times that by the number of cars in a fleet for an automaker, you're talking about hundreds of millions of cars and all that data is sitting out there. And they want to gather as much of that data as they can so that they can make their cars more energy efficient, less prone to repair, find out what, driving habits and things like that so they can better market and sell their cars to people. And that's just one industry. The number of these devices just exploding everywhere. And no matter how big of a pipe that you put in for network, you're going to saturate that pipe eventually. So we've been working really hard at Intel to come up with strategies to help organizations get through this transformation into a more data center without walls kind of architecture, multi-hybrid cloud architecture. There's lots of things that are going on when you start adding now cloud technology, public and private clouds, and all. It's just kind of a nightmare if you're a data architect in any way, shape, or form. So we're doing our best to see what can we do to help out in the situation. But to understand this, we have to drill down a little bit into an area that I love. I'm a software developer by trade. And so everything, as any software developer knows, everything can be solved by software, right? We're so arrogant that we can solve all the world's problems by software, that it's no big deal. We'll just write some code, that'll fix it. But there are some profound problems that are out there that make it more difficult to deploy applications out in this big ecosystem. One of them is that there's no common physical platform. So when I write an application, especially in the IoT space, I'm writing an application to a specific type of hardware. I can't just write it one place and it run everywhere a lot of times. So this slows down my deployment of applications. Sometimes, especially in my job now, and I'm in public sector and government now, they purpose build hardware and software together. And your development times just go through the roof. It's no longer 6 months to turn a new product or a new offering out there. It is 5 to 6 years. And this is an old way of thinking where I buy hardware for a specific application and get it up and running. Hardware is not being reused effectively. It's just really hard to then integrate all these different applications together. And that's where you get your real value out of your data, is when I can start using my data in different ways than what it was originally designed for, or through the application it was originally designed for. And then also another major problem that we're seeing in these ecosystems that are starting to emerge, where I've got devices scattered all over in the cloud, in my data center, out in the wild, is my attack surface has increased dramatically as well for cyber attacks. So, and I think we've all seen this with like ransomware that's out there, you know, in some very high profile cases, and then in some not so big profile cases. Even small companies are getting hit with ransomware attacks because their surface area has grown, especially in this world of telework. We're all at home right now, probably. We've just extended the data center outside of the bounds of its walls. So we're seeing this happening. So let's take a look at, from the perspective of application developers, let's take a look at how things work or used to work. So the first one is, I can build applications for specific hardware. And this is how we all learned computer science when we went to school, or when we started programming in our parents' basement, right? We got a little machine, we wrote some code, it worked. Hey, I'm the best programmer in the whole world. Look at me. I made the game of Pong or whatever I did. It works great because all your resources are centralized inside a computer. Then we hook it up to an internet, and oh, now my application needs to run on another machine. And it takes some time and I get it up and running. But it typically, if I want it to run in multiple places, I typically do a lot of heavy lifting for that. And I don't really reuse the technology that I'm on. And technology, as soon as I finally get this up and running, you know, Intel, we got a new processor out that's, you know, faster, or new instruction sets, and I'm already behind. I've got technical debt that I'm dealing with. So these are some things that that happen in, and this is how we used to build things. Then we got really smart and we created hardware virtualization. And it was interesting, when hardware virtualization came out, everyone thought this is going to destroy the server market because everyone's just going to virtualize their servers. But it did something really fascinating. It actually made it easier to use hardware because now my application could run on different hardware all over the place. And it drove up consumption. So now, instead of being locked to one machine, I can run all over the place, right? And I had virtual machines. It started with virtual machines first. Then all of a sudden I got virtual storage and virtual networking. I now had this layer that let me provision hardware, both compute, storage, and network dynamically. So I could create new hardware that I could use for my application. And it drove consumption through the roof. More and more people were writing more and more apps, more unusual and interesting ways to do things. It's very, it did amazing things, but it caused some problems too. Some of the problems were now security. For the first time, I'm now running my application on a machine with other applications running on it. And other people accessing that machine that I don't know who these people are. So security starts becoming an issue with my data. Also, I may have someone else running on my machine that didn't write code very well, and they're hogging all the resources, right? They're not freeing up their memory, or they leave open sockets, and they've got socket leakage. And we call those noisy neighbors. So they start affecting my performance. I didn't get the performance that I got before. So, but these are things that a lot of the people in the virtualization world have dealt with. And they do a pretty good job at determining these things, especially if these are running in your own data center. You can monitor who's being a hog, right? Basically. And you can turn the crank down on them a little bit and say, hey, don't be so selfish with the resources. So the next thing that happened about, oh gosh, I can't believe it's been this long, about 15 years ago. And that was a new abstraction layer called operations abstraction, which everyone knows is called the cloud, right, that we have today. And what's fascinating about this is everyone points to Amazon as the cloud, but it wasn't the first cloud. It was the first commercially viable cloud. There were other clouds before that where they did resource sharing on hardware and things, but they had the business model wrong, but the same concepts were there. I could easily spin up virtual machines via a website or use resources that I could rent. And it became really easy now, even easier to spin up and tear down things where before I'd have to file an IT ticket and there's specialized portals. This they made easy. They created the easy button and made the operations easy. And this just skyrocketed the use of more compute, everyone's like going, oh, this is going to kill the server market. And the CPU, no, it just blew it up. It's even bigger now. What we found was as things are easier to consume, people consume more of it. Right? But it also introduced more things. Some of the things that it introduced was integration costs. Now, if I'm running in an AWS cloud or an Azure cloud, how do I get my applications to talk to each other or back to my own data center? Lots of, some more integration issues. Noisy neighbor now becomes a big problem because unlike in my house, and you guys kind of mentioned at the beginning, I have 10 kids. When it gets noisy here, they're all in my house. They're all my kids, so I can quiet them down through resource starvation, right? I put them on timeout. I could do the same thing in my own data center when I've got a rogue application going crazy. I can cut down on their resources, give them a little timeout. But in the public cloud, you're out there with everybody else. And so noisy neighbor becomes a big issue because now I've got to go talk to Amazon or Azure and say, hey, so-and-so is being a hog. My thing's slow. And they'll say, well, they really need that much. There's a negotiation that goes on. In your own house, that negotiation is not there, right? You're in charge. You can handle that yourself. So these are some of the issues with cloud technology that emerged. Now, over the last, I guess it's been 5 years, a technology that's really old, we're talking 20-something years old, emerged again. And that's containerization. And what containerization brought, which I thought was fascinating, was it now made it easier to spin up applications. Before I only focused on infrastructure and spinning up infrastructure, storage, compute network. Now I'm talking about services. And with the containerization ecosystem, I can now spin up several services across a vast number of infrastructure. In fact, a lot of times developers don't even care where it's running. Is it running in the cloud? Is it running in my data center? I don't know. I don't really care. It runs. And what the container industry did was they did something interesting. They took something that was difficult to do and they made it easy again. So now with a simple file, I can deploy a very complex set of applications or services that before took a lot of scripting and things like. They handle all that for me. But there was one caveat. The caveat was that services should be stateless, meaning they're not going to store any state inside the service. And that works great if you have data that's accessible across the whole ecosystem. Because believe it or not, applications work on data, right? This is a big problem. And when I was talking to the founders of Kubernetes and Docker, I said, hey, what about data? And they said, well, we created this abstraction called volume. That's all we need. And they said, data is complex. We're not going to deal with that. They said, our answer to that is data is accessible everywhere. So that's a big problem. That's a huge problem. And the reason that's a problem is because of the IoT space. Because my data is being collected out there on the edge, and maybe it's sitting in in one case, we were dealing with an energy company. It was sitting in an oil well, in an oil pump. There's an application running out there. There's data running out there. How do I get access to that data? When I deploy my service, how's it being deployed out on that well? Is that the right place for it to be deployed? Or should it be the data moved from that well up into the data center or into a cloud to be processed? And we found lots of different modes of where's my data. So IoT kind of exposed a huge problem with the container ecosystem, which was, everything's stateless and data is accessible everywhere. That's not true. So what we saw was a lot of people finding up ways to just move all the data into one place so I can process it there. And a lot of people have used technologies like data lakes to do that, where everything's going into one place. And now I can run all the applications I want. But it's not feasible anymore, especially when your IoT devices are generating petabytes of data. It takes a long time to move all the data, or as we all know with public clouds, I call it public clouds of Hotel California was for data, because you can check them in, you can get your data in the cloud pretty cheap, but moving your data out of a public cloud is very expensive. In fact, you can probably never leave, is what they say. So all these things around data, people have just kind of ignored. So we started looking at this data problem in this, from the history that we've had. Where did we come from? So there's some major issues that we have to deal with data. First off, and number one that we found was data governance. And data governance is it's a big, broad thing, but it talks about when do I get rid of data? Who can access the data? Can the data move? What are the policies around that data as far as life cycle? Does it have to stay there forever? Am I under regulations? All these things start building up around data. And that's why we've seen such a huge uptick. In fact, even by mandate of law in the US government, you have to have a chief data officer in all of the government agencies now, because they know that data is such a big problem and a big thing to deal with. But I can tell you, talking to a lot of these CDOs, it is mind-boggling what they're trying to do, because no one has created a framework to manage data effectively across this vast ecosystem that we have. So what do people do? They hire more people. That's good. They buy more hardware. I like that, right? That they're buying hardware. It pays my bills. They create new software and they're still not getting the results that they want. So they get frustrated. And now we're starting to see them become paralyzed. What do I do with my data? How do I grow my business? I just can try and keep things going. So what we did was we started looking at how can we develop an ecosystem of hardware, software, process, and industry standards on how we can develop what we call a distributed information management layer. Now, this layer is responsible for the orchestration of data across this whole ecosystem, both in your data center, outside of your data center, in the clouds, in your IoT devices. How can I manage data across that vast ecosystem and orchestrate it? And what I mean by orchestration is making sure that the application and the data arrive somewhere together at the same time so that I can get real value out of that data, whether I'm running real just basic analytics or I'm doing machine learning or deep learning, whatever the case may be. How do I bring that together at the right time within all of the restrictions that I have around data governance? Okay, it's a very, very complex problem. And what we found was that people were doing this piecemeal, and they still do piecemeal, one application at a time. And what happens when you do that is you don't get the ability to start looking at data across multiple applications or even workflows, right? So this data orchestration is a key aspect of that. Data management includes data governance. I have to govern this data. I have to have data lineage. Where did the data come from? Was it derived data? Was it raw, primary data? I need to know all of these things. Who can access the data? When can they access the data? When do I get rid of the data? All fits into this data management layer. And then the last thing that we had was a metadata manager, so that I have some way of describing the data that I have across this vast ecosystem. So we started building out this concept of the distributed information management layer so that we could simplify the jobs of these new data workers that we started seeing popping up everywhere. Now, I told you guys before, I can talk for hours on this. Are there any questions? Anyone want to interrupt me so far before we go on to the, some more in depth? Questions? Everyone's afraid.
This is Cesar Goulart. I'm a CIO of a predictive analytics firm. We're taking tons of data from clients every day, and I think you're describing the right problem. I think you're giving the industry a little bit too much credit when you think that people are paralyzed in the absence of this. I think people are just in a very chaotic state and ignoring the footprints that are being left all over the place and taking what they need, doing what they want, and sort of moving on, which is, I think, is a bigger problem that we need to deal with over time.
Oh, Cesar, I totally agree. In fact, I just got through, I did a presentation last week on something called data hoarding is not a strategy. Because I found the same thing. People will collect all the data, but they don't know what to do with it. They don't do anything with it. Harvard Business Review came out with a study, and they said less than 1% of unstructured data is analyzed. But everyone collects it and they're afraid to throw it away. And then 50% of structured data sitting in databases is underutilized or not utilized at all. So I totally agree with you. They're just like, I don't know what to do, but I know I need to keep it all just in case, right? So I think I should be happy with this, right? Because Intel, if you guys don't know, Intel does not just do CPUs, we also do storage devices. So we should be happy, right? We should be happy everyone's storing all their data and not throwing anything out. But we're not. We're not happy with that at all. We've got to help the industry as a whole figure this out. So any other questions or comments? All right, let's take a look. There's two aspects that came out in this architecture as well. One called security and one called identity. And before, I had identity and security as one thing. But I found out something really fascinating, and this was the CIO of Department of Navy. She really kind of just grilled me on the security aspect, and she goes, Darren, identity, you have simplified identity too much. And I said, you need to explain to me what do you mean? I mean, identity, come on. I log on, I have access to data. And she goes, oh no, so much more complex than that. Identity here refers to not just users, but applications, data sources, data itself, data identity itself, and the list, devices, the list goes on and on. So we pulled identity out as its own aspect to give it the focus that it needed. And what we found was that if I can put identity, just like we do when we log in with user credentials, if I can do the same sort of thing with devices and data and applications and services, then it gives me more flexibility when I start looking at use and data use across this ecosystem. So we made identity aspect a tier 1 member of our architecture. And then security as well. Obviously, security is extremely important. I now have data scattered all over the place. We believe in encrypting everything at rest, in process, in movement. You should be encrypting. Encrypting is pretty cheap right now as far as cost in performance. Almost all encryption, if you're not using in-silicon encryption, you're crazy because it's so much faster and more secure that way. We also establish a root of trust concept where I can attest an application is running on a machine that has been validated and attested. And the good news about this is I can, if set up properly with hardware root of trust, I can guarantee that anything running on a specific piece of hardware has been trusted, came from a trusted source, which will help prevent a lot of the malware that's out there today. And vice versa. Maybe I have a piece of code and data that together is top secret in my organization. It's on my IP. I can guarantee that it will only run on machines and be decrypted on machines that I have attested. So some great security concepts right there. But you still get attacks. We still need detection and remediation. So we've got some great ecosystem partners that provide that. And we show how all that fits together. So this architecture that we built up over time, we call the Edgemere architecture. It is something we call a conceptual architecture. As you notice, there's no real, I haven't talked about any silicon in here at all. And this is something that Intel focuses on building these conceptual architectures to find partners that can help build out these different layers in the architecture to improve the industry as a whole. Because just like we saw with virtualization and containerization, as we make things easier to consume, more people will consume them. So if any of you are interested more in the Edgemere architecture, you can reach out to me. I can give you more details. If you have some technology that you think might fit in one of these layers, please let me know. My job right now is to go out and find and start forming these ecosystems to help make this much easier to use for people. So any questions from anyone? No other questions?
I have another question if somebody, yeah, so what type of feedback are you getting? I imagine that you're taking this to different industries, and what type of feedback are you getting from industries on this model, specifically when it comes to the understanding of the problem. Because I've been on the side of technology trying to drive awareness of the need to create data governance programs. And the first problem that you run into is people don't realize it's a problem to start with.
Yeah, you're absolutely right. No, so I get a lot of head shaking and a lot of people like, oh my goodness, I don't even know where to start, right? They get, oh, this is going to be so difficult. I get that a lot, Caesar. So
and how do you respond to it? Because I've seen it at different levels, in large scale, at large enterprise, and in the smaller companies, and when people don't recognize that they need to manage their data, or some of the issues that beyond the technical team, and the things that are obvious to the technical team, that getting out there to the business so that they understand that they can embrace that you're having to create this additional layer that they see as complexity to solve a valid real world problem.
Well, you know, one of the things I show them is, I'll show them this picture right here. One of the things that I tell them is, whether you think that's complex or not, that's what's happening. So whether you do anything about it or not, it's already there. And without a information management layer, what happens is you spend all your time doing all of the parts of the information management layer, but you're doing it not in a repeatable manner. It's all ad hoc. So you spend wasting more time deploying applications and solutions than you should. So it's almost like showing them, this is already happening in your organization. You can get control of it, or you can let it spin out of control.
So this is Michael here, and I like,
I lost Michael. He went on mute.
Well, while we're waiting for Michael.
there has to be a purpose.
Oh, there's
place.
Michael.
Yeah, sorry. Everything has to have a place to go. In other words, there has to be a purpose for it. It has to be organized. You know, it can't just be, you know, random. You have to know what you're doing with it, why you're doing it. And what I find a lot is people don't understand their actual business model, and it's more their strategy. So their strategy is lacking, and so they don't know how to use the data because they can't correlate it to their strategy, and actually decide what to do with it and how to make use of it. And are you seeing that a lot as well too?
I am. I don't see that as much in government, believe it or not. Especially federal government, where I do a lot of my work. And I did probably 3 years ago, but since they created the mandate to have a CDO, you started seeing data strategy really have a big play. And so they have developed their data strategy in conjunction with their business strategy. Now, but in industry, it seems to be a lot more reactive. So I agree with you, Michael. They don't know quite what to do yet. So that's why I bring this little chart up. I call it the information management maturity model. And what's fascinating is you can sit down with a CIO or a CDO and you can ask them, do you do any of these things? Do you collect all your data? Do you have uncataloged data? Do you use data warehouses? You know, do you have big data storage? You know, what's your storage? And you can find out real quick where they are as far as their data strategy. They may not think they have one, but they do. It may be very immature, is what you. So this chart is actually a really cool chart that I use quite a bit, where you can help them see where they're currently at, and then to see where they can move. Instead of saying, you need to be all the way at foresight, creating the future with your data, you can say, well, we're only down here at data collection. We don't even have, you know, that's our strategy right now. We're just collecting everything. And that's a good start.
So this is Tony Corrado. With regard to that, as you start looking at beyond the data center, my experience has been you very quickly get to truly huge amounts of data. You know,
Yes.
if you think about a terabyte of data, that's on a fairly fast network, almost a day worth of data movement time. And not to mention when you start getting into petabytes and more. I was wondering if you had thoughts about that.
Just the sheer volume of data, Tony? I
Volume
don't.
and managing the volume of data. I mean, I think the volume of data is fairly self-evident, but managing it, and when do you shift from moving the data to the application to moving the application to the data, and how do you go about that?
So what's really fascinating today is data most definitely is larger than the application sizes now. So there's a company out there called Nutanix. Some of you may know Nutanix. They did something really fascinating with that fact that applications are smaller than data. In their hyperconverged story and their hypervisor that they have for virtualization, they turned the problem upside down. And they said, let's manage the data and move the applications closer to where the data resides. And in doing so, they're able to actually spin up applications much faster than before. Because traditionally what people would do, they separated data and applications. But then when they came time to run it, they'd say, well, I got to just move all my data back to a central place where my application is running. So we're already starting to see some of this happen, where I know where my data resides and I start deploying applications there. I've even seen this in the container ecosystem. People are tagging pods, or they're tagging machines with certain data that's accessible there. And then containers are being deployed based off those tags. So you're already starting to see some of this happen. What we would like to see is this be even more dynamic, where it happens based off of policies and governance rules that are established by your data scientist or your CDO that has all your governance laws in there, right? So it will tell you whether the data can move or not, and then your orchestrator will then make those types of decisions. So it's very new, Tony. I'm not seeing a lot of people really take advantage of these things yet, but it has to come because there's just too much data to move.
Thank you.
In fact, it goes on to this. This is the major shift that we see happening. And these are the two, what we call generalized approaches to data processing. And I would say 95% of the people are still in this centralized processing. Copy all my data to one place, typically a data warehouse or a data lake, and then run my applications against it. And that's just not going to cut it in the future. So we're pushing really hard for a distributed processing model, where if I can push analytics out to the edge as much as possible, I should. And don't move the data unless you have to move the data. So in this model, a great example, and the reason I put a camera there is because camera data is so large. But I can push an AI neural network, model out to an edge device, and I can do object detection out there, and then only send object data back instead of the whole video. And the benefit to that is like 1,000-fold. I'm not sending a 4K image down. I'm only sending object detection data down. So huge benefit by processing and doing inference on the edge. And there's been a lot of success cases in this already. But it's still difficult to program and manage this application that's now running across 1,000 cameras. And then how do I aggregate all that data and even run deeper inference from the objects that I'm receiving from all this data? Like tracking someone moving through an airport or through a city. Right now it is painstakingly done with lots of data. being moved to a central processing. There's a great paper out there written by Martin Fowler on data mesh. And I know Martin from years ago. I think it's a brilliant paper on why we need to move to this more distributed data mesh is what he calls it. And other people call it a distributed data lake model. Very, very important. Good question. Thanks, Tony. Any other questions from anyone?
I have a question.
Yeah,
Don't most people, so when you talk about edge computing, right? In my experience, most people move their data, move their compute into the cloud, right? Because they can't afford to compute the data locally. They can't afford to get access to compute resources that will give them results in a timely fashion. So isn't just pushing the compute to the edge just an on-premise cloud or an on-premise data center?
No, you'd be surprised on how much computing we're starting to see being done in the devices themselves. Cameras, especially cameras, just because they're an easy target because there's so much data there. But smart cameras are now being outfitted with neuromorphic processing units. And these are like single watt, 2 watt processing units that can run inference on the edge. So pretty cheap. I mean, when you talk about power envelope and even cost, they're pretty cheap chips. In fact, do I have mine? I have one on a USB stick. Where was it? I had it on my desk and my kids must be playing around with it. It's an inference engine on a USB stick about this big and completely programmable where I can drop a neural network on it and hook it into even a drone. They've done these with drones. They'll just jam it into a drone and I can do inference right there on the edge. It's very slick stuff. So we're starting to see, that's why this push to IoT is starting to happen. The CPUs, VPUs, visual processing units, NPUs, neuromorphic processing units, all these things are getting smaller and cheaper where I can put them on a thousand machines. A great example, something similar to this, the military is using, and they bought 300,000 of these small chips to do inference on the edge at a cost of like $20 a piece. That's dirt cheap for military grade stuff. So yeah, we're starting to see more and more compute out there closer to the sensors. So what we're talking about here is preparing for that. Now, one thing I want to bring up, and I have it in here, it's what I call information modes of operation. Because you brought up all of these, but I want to make sure that you understand, we're not saying that we move all the applications to the data. That may not be the right answer. So in this architecture, we have to support both moving data and doing it at the right times, right? And also moving applications. And then also another one, which we call data exchange. And data exchange says I break the application up into smaller chunks and I process the data where it resides and send aggregated results up to central where I'm doing additional processing. And I can do it in a way that I can keep all of the rules and regulations around data sovereignty or around data governance and privacy. So the best example I have of that is this one right here. So, and we've used this example with something we call the Collaborative Cancer Cloud in the Northwest, where cancer organizations, research organizations, wanted to share data, but because of HIPAA And because they don't want to share all the data, because whoever comes up with the cure of cancer, that's like $1 trillion industry, right? So they want to be able to share clinical data with each other without exposing their whole databases. So we came up with this really cool concept called the data exchange. And in this, you can send your queries into the portal, and then you query the portal. The portal will then send its queries and analytics out to the people in the exchange, in this case, the Department of Defense and Department of Energy. And then a policy gate is established at each location that says, I'm going to allow whoever accesses, I'm going to allow you to see my data, but you can't see, in the case of Collaborative Cancer Calendar, you can't see the person's name or where they lived or any patient ID number. But you can see their age and the disease that you were researching for. So I can run my analytics without exposing my whole database up, and I can filter the results coming back into the portal. Now, these data exchanges work really well as long as everyone in the exchange is willing to put their data in and willing to expose enough data that you can get some valuable analytics out. And then the cool thing about this too is they were sharing the analytics results that they were running as well. For Intel employees, if any of us are diagnosed with cancer, our information can be, if we want, we could be part of that collaborative cancer cloud and get the research and all of the trials that are being done across 12 different cancer research institutes. So we can tailor our medicine, our treatments based off of all this research that's being done on all these different sites. It's a great way of showing data coordination or data exchange. So this is another mode of operation that we have to be able to support in this architecture. And we imagine there are many more different ones that will emerge as we're starting to see more maturity in data management. Great question. Any other questions from anyone or comments?
Darren, this is Andrew. The slide
Andrew.
showing, the slide that you're showing here almost seems like a topology for data trust. If this is not that, have you encountered folks that have been talking more and more about data trust?
I'm starting to hear that term used more and more. I'm starting to hear data trust used. And this is very much like a data trust. I would say data trust is even more. I'm guaranteed where the data came from, that it's attested. So I would add another layer of that on top of this to have a true data trust. But yeah, no, I'm starting to hear more of that, Andrew.
Hey, this is Michael. I've got a question too. One of the things that I've seen a lot of is siloing and duplication of data because of basically siloed systems, collecting this data here, and I'm not talking about the IoT or the edge problem. I'm talking about having to reduplicate the data because it's used in this system and this system and this system, and that siloing. And what are you seeing as far as the trends?
Oh, I see that all over the place. And it's disconcerting because one of the things that we see is the golden data. Where is the golden data? So what people have started doing is they say, well, then I need to put all my data in one place so I don't have multiple copies of the data. So I see people moving to massively large data lakes in that respect. I think that's a Band-Aid on a huge problem of data management. That's why we came up with the architecture, because I don't believe that throwing everything into one place is the right thing to do. Because now you get data drift between the gold version of the data and the copy that you've made. And that's a big problem. So yeah, I see it all over. Right now, people's gut reaction is to just throw it all into a big data lake. And
So do,
go ahead,
do
Mike.
you see it, because there's two parts to data. There's, you know, collection and analyzing type data, like you were talking about the oil wells, or you talk about cameras or those types of things. And then there's operational data. I've got customers, inventory, tracking, flowing, all the things that are going on, even between suppliers, all the different things that are happening, that type of operational data. Are you seeing that consolidate more to enterprise solutions rather than here's this inventory system, here's this shipping system, here's this, et cetera, et cetera, et cetera?
I'm seeing actually companies move to more SaaS models for operational data. So they're punting. They're saying, I don't want to manage this anymore, so I'm going to go to an online ERP system. Or I'm going to go to an online CRM, like Salesforce or something like that. So I'm seeing companies do that instead, which I think is kind of funny because now someone else actually owns and controls your data. I mean, the crown jewels of your data, which is your customer list and your supplier list. So I'm seeing companies move that direction. So
no, I appreciate the answer.
Yeah, another crazy thing I see happening, and a lot of the cloud service providers will do this, is don't worry about your data, put it all into our repository. So if it's in Azure, it's Storage Spaces Direct. Just have one big Storage Spaces Direct place, and we'll manage that you don't have copies of it. And you know what? They do a good job at deduplication on the back end of that. Or if you are in Amazon cloud, they'll say, put everything in an S3 container. And then all your applications can access it that way. It's very, to me, it's just putting a Band-Aid over a more profound problem that needs to be managed.
So you mentioned punting, and forgive me because this is an important part that I'm seeing in the industry and the trends. When they punt it, essentially what a lot of times it seems they're looking for is they're punting it not to have someone else do the system. They're essentially saying, why don't you do this? Tell me what I need to do. Tell me, basically, how do I do my CRM stuff? How do I do this stuff? How do I do that stuff? Just tell me and I'll do it. So it's more profound than just moving the data. It's actually, they're not just relinquishing the data as you were talking before, they're actually relinquishing their competitive advantage and their business model, basically not wanting to think about it.
Yeah, but that could be a good strategy though. You're outsourcing something basically, right? You're outsourcing it to Amazon or to a Salesforce. But if your secret sauce, the thing that makes your company unique, is not managing a CRM system, then don't. Then have someone else manage it. And this, I tell people this all the time when they're looking at their migration to cloud, that first off, I tell them it is a multi-cloud strategy should be a multi-hybrid cloud strategy should be your strategy, meaning not everything's going to a cloud, everything's going to a multi-hybrid cloud. So some things will be on-prem, some things will be in Amazon, some things will be in Google, some things will be in Azure or IBM Cloud, or maybe even a small tier 2 CSP. The key here is that I tell them, what are you good at? What is unique about your business? Don't outsource that. Keep that close. Keep that close to you and focus on that makes you unique. I've seen people hold on to their email servers, to Exchange servers. And I go, Why would you do that? Well, because it's important, right? I got a guy that does Exchange. Well, guess what? Take that guy that does Exchange, train him up on something that makes your company unique. Focus on that. That's where you get your competitive advantage. That's where you can really make a difference. Because if you have someone spending their time just managing email, that's not making you different. That's not making you competitive in the marketplace. So use the clouds to your advantage this way. That's what I tell people.
Thank you.
Great. Any other questions? I think we're at the top of the hour, so. All right. Well, hey, thank you very much, Andrew and Deborah, for letting me talk today. It's been fun talking to you guys. If you want to hook up, I'm on LinkedIn, or you can send me an email, or Andrew knows how to get a hold of me. Andrew and I talk all the time. So thank you again for having me today.
Thank you so much, Darren. We really appreciate it. And thank you, everybody, for participating. Have a great day. I think everybody's going. Thanks so much, Darren.
Thank you, Darren.
Hey,
Great.
no problem at all. I'm going to stop the recording.